Hi, everyone. Welcome to today's Greentech Media webinar. My name is Scott Moskowitz. I'm the head of GTM Research's Renewable Technologies Group. And today we're going to be chatting about maximizing PV system performance with single-axis trackers. We're going to be talking about bifacial modules and some other exciting system performance technology. Thanks for joining us. This is a topic that's brought to you with support from our partners at NEXTracker, which is the world's largest solar tracker company. Welcome to all. Thanks for joining us. So for many of you, if you've attended GTM webinars in the past, you might notice a few changes. We got a new platform here, and it should be just as good, hopefully even a little bit better for y'all. So what you'll notice now is that speaker bios are accessible from the top tabs if you click on each speaker's name. Like always, you can click on, there's a link on the left-hand side of your screen. It's going to let you download a copy of the slides from today's webinar. You can download everything in a PDF. And most importantly, note that the Q&A module on the left-hand side of your screen is wide open. You can enter questions at any time during today's presentation. They'll come right through to us on the back end. We'll save about 10 to 15 minutes towards the end of this presentation to go through and answer some of those. And we encourage you guys to ask as many questions as you can, because even things that we don't have time to get to on the webinar, all of your questions and contact information comes through, and hopefully we'll get back to you in some way, shape, or form. So please ask away. And then lastly, this webinar is going to be archived on greentechmedia.com for the next 3 months. So feel free to share the registration link with your colleagues. We hope that if you have a colleague or a friend that can't watch today, they should be able to watch anytime in the next 90 days. So with that, we'll go ahead and get started on today's topic. If you're just now joining us a few minutes after the hour, we're going to be talking about designing PV systems with bifacial modules and some next generation tracking technology with our friends from NEXTracker, as well as their partners at Clenera. We're joined by Dan Sugar. He's the founder and CEO of NEXTracker. This is his 30th year in solar, so he's just about seen it all. He's been talking about bifacial modules for a long time, probably longer than most of us have been in this industry. We have his colleague Venkata from NEXTracker, as well as Dustin Shibley from Clenera, who's also going to speak quite a bit. So thanks for joining us. We're all glad you're here. Just a few things just to kind of frame the rest of our discussion today. It's of no surprise to most folks that the global utility scale PV tracker market has blown up in the last 5-6 years. It continues to grow. We expect it to grow and ongoing each of the next 5 years. And it's not just in Europe and the United States anymore. We're seeing gigawatts of tracker installations, and I mean over a gigawatt was installed last year in India. We're seeing a gigawatt in over a gigawatt in Australia, hundreds of megawatts in new markets like Mexico, Brazil. Chile has been a good long-term market, also seeing a significant amount of demand in the Middle East. So growth is continuing, and it's diversifying into many new solar markets around the world. So there's a lot to look forward to, and it's an exciting market. Trackers have grown as the overall market's grown, but they've also grown a little bit quicker because they've been taking share from fixed tilt projects. As the price of trackers have come down, we've seen trackers work in more and more places. We've seen tracker projects in the northern United States. We've seen them in Canada. We've seen them in traditionally low-cost markets like India. And for projects that in the past would typically have been would have been a fixed tilt or some other type of project are now going tracking. And in most markets, it's the obvious choice for utility scale solar. So it's an exciting market, and lots of things are happening. It's also a maturing market. There's a lot. The market is entirely single axis. It is predominantly single axis. There's still a few dual axis tracking projects that get installed here and there. But it is pretty much entirely single axis. And there's many different types of trackers that are being installed. The two predominant types, centralized and decentralized tracking, take up the vast majority of share. We've seen a significant growth in decentralized tracking over the last couple of years, largely due to the success of NEXTracker. This slide shows that they're the #1 tracker vendor by shipments globally. That was last year in 2017. They were the previous 2 years as well. Though there are many successful tracker companies, we've seen growth from a number of different firms as the market has grown. But there is nuance to each of these tracker technologies. They are differentiated from each other, and there's a lot of interesting things happening. So we'll spend a lot of time today talking about some of the next trends that tracker vendors will be paying attention to, as well as some of the things that they'll be introducing themselves. So we'll send it off to Dan and his team and Dustin at Clenera to talk more about those things. A quick plug from GTM. We hope if you want to sign up for more webinars, just go on to greentechmedia.com. We also hope you'll join us at some of our upcoming conferences throughout this summer and fall. If you use the code webinar on greentechmedia.com/events, you should be able to get 15% off. So we hope you'll join us there to continue these conversations. And with that, we're going to go ahead and pass it off to Dan. Dan's going to tell us about, Dan and Dustin and Venkata are going to tell us all about some of the things that they're working on, and we hope you guys will ask questions and enjoy the presentation. So Dan, it's all you.
Thanks for the great introduction, Scott, and thanks for joining us, Dustin. Clenera is an amazing partner and developer out there. We're really excited about what's happened with obviously the growth of the industry, the cost progress, and seeing trackers come in, having been carrying the tracker flag for 30 years, to see trackers come into such a great position. I think the market trend Scott showed was great, and I think if we looked outside of China, the percentage of tracker share would be significantly larger. So solar is going to keep growing. I think it's going to keep accelerating in growth because we're at that great cost trajectory, and we need a robust industry throughout the value chain, solar panels as well as trackers, to serve this global market. And the need for trackers, the imperative, as solar grows in higher penetration in grids, the value of trackers keeps growing. We're already seeing curtailment in the middle of the day in California and some other markets. The trackers provide power from early morning to late afternoon. So we look forward to working with all our colleagues on this, serving the global market. Okay, NEXTracker and our parent company Flex on one slide. We're manufacturing and serving 5 continents at any given time, and we have over 13 gigawatts delivered or under fulfillment today. With our Gen 2 platform, which was released about 2.5–3 years ago, we have 10 gigawatts delivered, and that platform has performed extremely well in really incredibly extreme weather conditions. We previously published our systems. 32 of our systems went through all the hurricanes that happened in the Northeast and Southeast a few years ago with zero issues. Our parent company Flex is an investment-grade company, and that's a big deal when our clients are developing projects that could be valued at $100 million or even $1 billion. Flex has $25 million annual revenue and a very strong balance sheet and cash flow position. I believe my understanding is of let's say the top 5 tracker providers, we're perhaps the only one with an investment-grade parent. So that's important for us as we think about the long-term ability to serve the market. Okay, I'd like to pull back, speak to the imperative for ongoing yield gain, and then talk about what we're going to massively geek out on trackers and performance. I look forward to everyone's Q&A. So GTM published last week the latest update on the LCOE of PV, as shown on the right with the blue circles. And last week, 8-Minute Energy signed on for a 300 megawatt project at $23 and change per megawatt hour. So 2.4 cents a kilowatt hour fixed over the life of that 30-year. I mean, that's just staggering. So we're lower cost than gas, which is shown on the yellow bar. We're lower cost than coal. We're lower cost than nuclear. This industry is going to have ferocious growth ahead of us. And the industry has done a great job lowering the cost of solar but there's really only so much you can keep squeezing out of that. We really need a healthy and vibrant industry. And today, a lot of the industry is not generating sufficient profit. We've seen presentations on that for solar and others as they look at the module landscape. And, we basically need to, we're there on cost as shown in the graph, but we need to really focus on other things to keep driving the competitiveness of solar. And yield is really the thing to focus on. So trackers have basically, as Scott mentioned, in sunny areas are the most optimal way to optimize the levelized cost of energy. And in virtually all markets, horizontal one-axis tracking has emerged as the most productive way to follow the sun. Well, we've been thinking about how to follow the sun for a long time. And so back in the 80s, there was a clock that kept the solar panels pointed perpendicular at the sun throughout the day. We figured out with my colleagues at PG&E and Integrated Power that there were better ways to do it. In 1991, we published the backtracking algorithm, which was able to generate a couple percentage more yield for horizontal trackers. That became prevalent in the industry. And that was really helpful and works really well if the site's perfectly flat and perfectly sunny, but that's not the real world. We've known for decades there's better ways to do this. And so what we needed was a smart control system and the software to do it. We acquired a machine learning company 2 years ago to help us accelerate the next generation platform. We're going to be speaking about that. NEXTracker has had many industry firsts in innovation with trackers and connectivity. I'm not going to cover all these technology points now. All this information is available on our homepage. What I am going to point out is that in order to do something like TRUECAPTURE, smart control system, that needed to build on innovations in connectivity that we had achieved throughout our history of innovation. So we had the balanced tracker, which enabled us to do the first really long trackers and really reduce the amount of energy to rotate the tracker. And then we used a smart solar panel to actually move it and collect very rich data about the system, such as every row has the angle measured accurately with an inclinometer. We look at the motor current and other key metrics that are important, and then communicate with a wireless mesh network and collect that data to be able to then optimize each independent row relative to itself, to its neighbor. And to be able to do this, these power plants are serious business. And the North American Electricity Council has the Critical Infrastructure Protocol for communicating, NERC-CIP. Our systems are compliant with that, and that's necessary for monitoring and also updating firmware or other things required to keep these systems current. These build on prior innovations. Venkata, can you go a little deeper on how?
Yep.
Oh, I'm sorry, I skipped one slide. Not sure how that happened. Okay, first, quick intro, and then Venkata will speak to TRUECAPTURE. So, as I mentioned, the real world isn't flat. Systems are not built to perfect construction tolerance. The upper photo is a photo I took of a linked row system built in South America a few years ago. And the system performs well in the middle of the day, but in the early morning, late afternoon, there's a lot of shadowing that happens due to grade undulations and construction variances. And, the way a crystalline solar panel works, if you shade the bottom cells, the whole string dies. So that's really bad. And as we spoke earlier, in cloudy conditions, there's an enormous opportunity to increase the power. Like if it's late afternoon or early morning and it's really cloudy, but the angle of the sun is perpendicular to the panels, if you rotate back closer to horizontal, you'll see a absolute increase in the amount of power in those conditions by very large numbers, like 10 to 12 to 15% on the overall system. So this is the opportunity. Venkata is going to go through now and speak to how we get it done.
Thanks, Dan. Hello, my name is Venkata Abbaraju. I work at NEXTracker, focusing on control systems and TRUECAPTURE. I want to start with showing a few pictures on what we see at our project sites and several fixed tilt as well as several other project sites. So the picture to your left shows this is something you see every day looking at solar plants. It looks relatively flat, but you take a closer look at that, you see this row-to-row variations. In this case, this is caused because of the terrain undulations, and which, as a result, when the trackers are doing their standard tracking, which was, like Dan mentioned, was being done since 1991, you see inter-row shading, and you can see here different levels of inter-row shading because of variations in row-to-row heights. And this is another example where the terrain is relatively flat, but the soil conditions caused some construction variations where you see the rows, elevation of the rows vary quite a bit. And this also causes row shading. And the row-to-row tracking aspect of TRUECAPTURE addresses exactly that issue. With this control algorithm, we optimize, we feed in the terrain information, and it optimizes the tracker operation throughout the year for every day, every hour, essentially every minute of the year. And you don't need to go back and touch it and change the tracker parameters or anything like that. It tracks in a way, it's optimized in a way that your shade is avoided or minimized, and your DC block level energy is maximized. And this is a sketch here, it's not a real site. It's showing how the shade, the undulations are causing inter-row shading among trackers due to east-west undulations, and how TRUECAPTURE is solving that. And this was possible because of our independent row. If you have a mechanical linkage that constrains all the trackers to be at the same angle, this is not possible. Or and with our distributed control architecture and communications, we were able to do this and solve this inter-row shading issue. The other aspect of TRUECAPTURE is diffuse tracking, where by tracking near horizontal position, you increase the view factor of the sensitive PV area, and you capture more plane of array irradiance. And this is a dynamic, real-time adjustment that happens on the site where you're harvesting more energy under diffuse conditions. Under diffuse conditions, there is no beam component or very little beam component, and light is coming from isotropic, and we are positioning trackers and tracking them to maximize the yield there. So I just want to show you guys how the power curve, an example power curve, how it looks like on a typical day of TRUECAPTURE operation. And if you have inter-row shading, which occurs mostly during backtracking time in the mornings, early mornings, and late afternoons, you, by operating in a TRUECAPTURE mode, you generate more power out of your PV array. And in the middle of the day, this is showing a cloudy scenario where you, by doing diffuse tracking, you improve the energy production. And these both technologies work in tandem, and depending on the radius conditions, if it is cloudy, the system will go to diffuse tracking, and if it is sunny, based on the terrain, it will do row-to-row tracking and improve your energy production. That is the principle of TRUECAPTURE in a nutshell. This is for improving your PV system performance in a real-world conditions where terrain undulations and cloudy conditions occur. So with that, I'll transfer to our partner, Dustin at Clenera.
Yes, thank you, Venkata. This is Dustin Shively. I'm Director of Engineering for Clenera Renewable Energy. And first of all, I'd just like to thank Dan and Venkata for the opportunity to participate on this webinar. And just in general, working with NEXTracker is always great. We appreciate all of the all of the work that's done to decrease costs and reliability, of course, but then this sort of effort that goes into maximizing energy production really is the sort of partner we like to see in the industry and lower that LCOE all around. So thank you. We'd like to present a few details about a particular site that we have operating that has TRUECAPTURE, the row-to-row aspect of TRUECAPTURE enabled in Alabama. But first is just a brief introduction to Clenera. For those who may not be familiar with the firm, we're a solar shop based in Boise, Idaho. We work with our investors to develop, acquire, construct, own, and operate solar PV plants. We have about 18 operating throughout the country, totaling around 650 megawatts DC, with approximately another gigawatt starting construction in this year in 2019. We're seeing, just as everyone in the industry, we're seeing growth outside of just the traditional sunny areas. Down to the next slide, down into the southeast, we're seeing a tremendous growth in solar throughout Georgia and Alabama, Mississippi, Florida. And along with some of these locations comes terrain that's not the flat site out in the desert that the desert Southwest had previously seen solar growth. So with that challenge comes some aspects of the design that are more site-specific. And a traditional single-axis tracker may not be optimized for that site, and therefore you can't produce as much energy as you could with a system that's actually optimized for that site. This not only applies in the southeast, but it applies everywhere, even in the desert Southwest, with sites that are maybe not as ideal from a terrain standpoint, but might be more optimal from an interconnection or transmission standpoint. Previously might have been looked over, but are now being explored as solar continues to grow and those sites become more and more limited. This TRUECAPTURE technology enables those sites to not only be built, but actually maximize the energy coming off of them. So the site in particular that we'd like to discuss today is a 111 megawatt DC plant that went online late last year in Alabama. It's about 1,100 acres, pretty segmented site with rolling terrain, trees, quite a bit of civil work that was done to level as much as you can, but that's always a cost benefit also in to what degree do you cut and fill and grade the site versus have maybe an impact to energy generation by not doing so, or additional construction costs. So throughout this site, we have some undulating terrain, some east-west slopes that, as Dan and Venkata pointed out, certain times of the day with a traditional backtracking scheme have shading on one row of panels from its neighbor, which you can see in the figure in the bottom left right there. With traditional backtracking, we're not able to adjust each row's angle of rotation independently. So those sorts of situations, not only do you not know about the height difference to adjust what the backtracking might be for that entire block, but you're not able to know if one row should be adjusted independent of its neighbor. So we've now enabled TRUECAPTURE on the majority of the site, but in particular, there's a few power blocks that we have turned TRUECAPTURE backtracking on for one day and then off for the next, and alternated back and forth. That really provides us with an opportunity to compare on what the real benefit is, outside of just geometry and doing the physics ourselves on a piece of paper. On the following slide, well, here is just another picture of the undulating terrain. You can really see, obviously it's a single axis tracker, so those rows are on north-south axes. So this is an east or west facing slope. When the sun is setting in the horizon of this picture, with traditional backtracking, many of those rows on the slope are shading one another. And the more optimal configuration is to turn them a little bit flatter and allow the entire block to maximize energy production, even though you might be reducing energy production on the very top row of that hill. So this figure is just a daily energy production curve from 2 consecutive days on one power block at this plant in Alabama. The gray area is the day with TRUECAPTURE not turned on, and then the orange, which is behind it, and you can see it kind of sticking out on the shoulders, is the day when TRUECAPTURE is enabled. So during those times when we're not clipping, which is the morning and the afternoon, that's exactly when the shading from one row to the next is occurring the most. So that's where the most benefit could be had by enabling TRUECAPTURE. So you can see that on the second day when TRUECAPTURE was enabled, the orange sticking out from behind the gray is occurring in the morning and the evening. If we're clipping during the day, there's no additional energy generation that can be had. But this is one example of the benefit that we get from TRUECAPTURE, and in this case, it's about 4.3% more energy production when the row-to-row tracking was enabled. 4.3% is huge. I mean, if we're talking about these very competitive PPA rates, ever reducing levelized cost of energies, it's anything that you can do to eke out more energy from the facility, the better. And the best part about TRUECAPTURE is it comes with technology that's already implemented at the site. NEXTracker has row-to-row control system and the ability for each row to operate independently. So that technology exists. When we look at the gain for TRUECAPTURE over the few months from March to the present when it was operating, we can see that overall there was about a 3.23% energy gain by utilizing TRUECAPTURE at this site. Again, this is just the row-to-row TRUECAPTURE, so the undulating terrain operating one row independent of its neighbor. We have not yet enabled the diffuse light aspect of TRUECAPTURE, which, as Dan and Venkata described, is when the modules go to a more horizontal position during diffuse light conditions. The modeling that we performed at this site does show that there is a potential for an additional percent or 1.5%, maybe possibly even above that, in addition to the row-to-row TRUECAPTURE. So overall, from the period that we've had this enabled, we would be expecting somewhere on the order of 4 to 5% energy gain by utilizing TRUECAPTURE. Pretty significant. Now, next, I believe Dan, and I'll turn it back over to Dan and Venkata, who are going to go into a little bit more about other TRUECAPTURE case studies. But from Clenera's perspective, we've been very happy with the performance that we've seen, the implementation of TRUECAPTURE at the site, and then the real megawatt hour increase that we're seeing at the meter is significant.
Oh, thank you, Dustin. So before we go into other case studies, I just want to touch on the DC-AC ratio, clipping and DC-AC ratio and its effect on TRUECAPTURE. Like Dustin mentioned, the most of the TRUECAPTURE benefit, almost all of it, is coming from non-peak hours. It's coming from the shoulder hours when trackers are backtracking, when inverters is not peaked out, or it is coming in diffuse conditions when inverter is also not peaked out. So this is the measured energy benefit from TRUECAPTURE at DC-AC ratio of 1.45 at the site. And we took that and we in detail looked at how many clipping hours, how much time is clipped at different DC-AC ratios. And you can see the TRUECAPTURE benefit is nearly impervious to clipping. When you get into very high DC ratios, you'll see it dip a little bit because you're eating away from shoulders, the benefit away from the shoulders of the power curve. But most of the TRUECAPTURE benefit is realized even on really high DC-AC ratio sites. So want to touch on two other case studies. We've deployed a TRUECAPTURE, combined TRUECAPTURE, both diffuse and row-to-row running, and we did similar day-on-day-off trials in Mississippi. This is a project, 74 megawatt project, and we are realizing 3.5% more energy. And our customer from D.E. Shaw Renewable Energy Investments, Brian Martin and Dan co-presented on this data at Bloomberg conference in New York last month. You can see the presentation here on the YouTube link that's provided on the slide. And the other case study I want to touch on is, the slides are going back and forth for some reason. The other case study I want to touch on is Oregon. We have a 14 megawatt DC project in Oregon, where we deployed only row-to-row, and it's one of the highly undulating sites we've seen, and it's generating 3.9% more energy. So when we first came out with TRUECAPTURE last year, around Intersolar last year, we came out saying it generates anywhere between 2% and 6% more gain. And if your site is in desert Southwest, it's really flat with minimal undulations. You can see like 0.75% gain or 0.5% gain. If it is in these really sunny on the East Coast, where there is a lot of clouds, a lot of weather, and also really undulating terrain, you can see north of 6%. And that's what we are measuring for the past 6 months to 1 year. We are also doing a TRUECAPTURE technology report with an IE. We have an IE review of our technology and report on it. And multiple projects are getting financed with TRUECAPTURE, and that's where we are. The TRUECAPTURE is also applicable to First Solar and thin film technologies. We are not deploying row-to-row because of its linear shade response, so the benefit would be minimal. But diffuse TRUECAPTURE would yield in higher benefit than compared to a crystalline silicon module due to its superior spectral response, because it can generate more energy under cloudy and diffuse conditions and low light conditions. First Solar performance is expected to be better. We've just deployed TRUECAPTURE a few weeks back at a site in Tennessee, and this is the expected benefit out of cattle modules. With that, I'll transfer it back to Dan.
Thanks, Venkata. Early in my career in 1991, Mount Pinatubo in the Philippines exploded. There's a photo of it shown on the lower left. And at the time, I was at PG&E, and we maintained 16 very high precision weather stations throughout California. And we saw a huge drop in the direct normal irradiance that actually lasted for a couple of years before it tapered off. At that time, the largest solar plant in the world was a solar thermal project, a trough project built by Luz down in Southern California. And they had significant revenue shortfalls for a few years, north of 5% after Pinatubo went off. We've seen a lot of pretty wild weather going on recently. There's been a lot of wildfires. A number of volcanoes have gone off. El Nino, some extreme El Nino effects. And what the TRUECAPTURE does is it actually provides resiliency. You're not going to get all the energy back, if there's a lot of dust particles in the sky or what have you. But you'll get some back, and it'll a couple percentage back in these types of conditions. Well, TRUECAPTURE also provides resiliency if the site changes over time. For example, if there's settling of the piers and the foundations over time due to site conditions, geotechnical conditions, the TRUECAPTURE Smart Module enables us to be able to adapt and recommission the site with a great degree of autonomy. So this technology can help us deal with unknown conditions and maintain the financial benefits. Okay, I'd like to, we're going to switch gears, talk about bifacial. As I'm fond of saying, I've had a love affair with bifacial my whole career, virtually. I first bifacial was actually proposed by a Hitachi researcher Mr. Mori back in the 60s. The first time I got exposed to it was at the PVUSA project, which was a project the U.S. Department of Energy ran with PG&E, where I worked, and I saw a SolarX had a 20 kilowatt beta of this, and I just thought that was just a very, very interesting idea. When I was president of PowerLight, we were the largest provider in the U.S. We built the world's first 10 megawatt project in the industry later in Germany. And one of our supply partners was Sanyo, and I was in their office in Osaka in 2005, 2006, and they showed me a prototype of a bifacial module. And I just remembered seeing that back at PVOSA. I was like, oh, absolutely, we want it. We're going to design products around it. We gave them a large purchase order and basically worked collaboratively to co-optimize a product, and we developed some trackers. I'm going to show you some of those results now. So the first project we did, which is a famous project, was at the Nellis Air Force Base. And so this was a 14 megawatt project. We designed, manufactured the trackers, built. There's a patent on the trackers. If you look publicly under my name and trackers, you'll find the patent for these designs. And this was an awesome project. Of the 14 megawatts out there, 2 megawatts used the Sanyo HIT module, which we had co-optimized the parameters around. We designed a really state-of-the-art tracker at that time. It was called the T20 tracker. It was a two-portrait design where we had long rails supporting in a butterfly configuration, keeping the modules away from the tube and things like that. And we built this project and measured really good gains with the bifacial, incremental gains with the bifacial, over 12% and above. And this was very successful. It was visited by President Obama in 2009. And it sure was great for a president that was supportive of solar power. And thank God that our period of cost reduction in this industry happened when we had federal support for solar. So in current conditions, that would be difficult. But now we're at a place where we're winning on cost, so that we're going to just power forward on that. So this was a good design, and we learned a lot about building. We did a lot of measurements, both here. We built some additional projects with this design. We ultimately abandoned the 2P design because it required some pretty expensive rails that had to be built, and the GCR suffered a bit by extending the panels past the edge of the tube, and it turned out we didn't need that feature. The next project we built, we basically went back to horizontal tracking over the tube. We put the bifacial modules over the tube. In this particular case, we tilted the modules. And this is just an awesome array. We built this module at the Springs Preserve, which is a water history museum in Vegas. It's open to the public. Please go visit it. You can drive and park under this amazing bifacial old array, which has a stretched membrane dual purpose of both keeping your car cool and providing extremely high albedo back onto the other side of the module. So we measured 17% bifacial gains on this array. And so this was just a great experience for us back there. But we had built up, when we designed the T20 tracker, we had actually commercialized really link row trackers back at PowerLight in the 90s and 2000s. We built dozens and dozens of projects, and then we applied the bifacial array to this in a number of configurations and got experience as we went. Okay, well, let's look forward now for today. So the industry finally is moving toward bifacial at scale, and that's enabled by the technology that's happening in silicon. Manufacturers are moving from aluminum back surface field to high quantum efficiency designs with HIT PERC and IBC and other designs. Thinner wafers, better casting, even on multi, we're seeing bifacial. Good backside passivation and texture are enabling this. The other thing that's really important is that the glass now available, you know, it used to be like 3.2 millimeters was what was available in volume at low price. Well, now we're seeing really good 2 millimeter and other thinner gauges. So you can go double glass, and that's helping the bifacial move forward. So when we launched NEXTracker 5 years ago, we conceptualized our tracker around a bifacial design. I'll take you through a few of the elements for why this is so productive in this format. The main thing was we had this balanced, we wanted a balanced tracker where essentially we're suspending 8 modules plus or minus between our peers. So there's no shading on the back from peers and bearings and dampers and things like that. So we're basically staying clear of that. We specifically went with rails that were short and tall and tapered toward the center. There's been some really good ray tracing and other tools. Venkata will go a little bit deeper. You know, you don't want the tall rails that we had done back, you know, when I was at Powerlight, as we put out at NELLIS, because that shaded the edge cells in the module. And we specifically chose a round reflective tube, which provides additional benefits for bifacial we'll speak to in the seminar we have upcoming at Intersolar in a few weeks in San Francisco. If you'd like to participate in that, let us know. It's for customers and independent engineers. So we basically put this out there. We've been testing bifacial at our Solar Center of Excellence here in Fremont since 2004. We'll speak more to that in a moment. We had some customers asking about, well, what's the impact of this tube on the back, like for bifacial? So we actually mocked up and were able to test what the entitlement would be for if there were magically no tube or any kind of anything around the panel, what's the impact? And it's significantly less than 1%. Venkata will be speaking to how that correlates with PVSYST in a few moments. People like to throw PVSYST under the bus, and that software's come a long way. But what was really it was a pleasure to see that the PVSYST results correlated almost perfectly with our empirical results in the field, and Venkata will be speaking about that. Okay, so Solar Center of Excellence, as I mentioned, this was established in 2013. It's here at our Fremont headquarters. It's 3 acres. We have 64 types of PV modules that are either out there or have been tested. 4 types from 4 different trackers from different tracker manufacturers, 5 different inverters. We also are testing storage, battery storage. And the purpose of this facility is for extended life cycle reliability and to really demonstrate also a number of technologies and look at the interactions between them. We also developed an accredited NAPCEP training facility. We've trained hundreds, probably thousands of people there, and this is open for customers, EPCs. If you'd like to organize a training, let us know. And yeah, we tested bifacial, starting with the SunPreme technology back in 2004. Go ahead, Venkata.
All right. Thanks, Dan. Appreciate that. So, like Dan mentioned, we've been testing bifacial panels and the systems in our backyard here in Fremont for the past 3 years. And here are some of the results that we did from the test we did last year. We tested a bifacial modules on our single-axis trackers, our flagship product, NX Horizon. On the module with 90% bifaciality, yielded 13.8% gain on bifacial. And this is on a GCR of 42% and the ground measured albedo of 18%, which is because of this combination of gray and white rock on the ground here. And the bifacial, so we had test modules built with the same wafer for both bifacial and monofacial, and we were able to do comparisons on bifacial and monofacial side by side. We chose the same efficiency front side and this test. The next slide. So 2 months back, PVSYST can run bifacial simulations on single-axis trackers. And it's really good to have a easy user-friendly tool to measure all the effects, all the impacts on the bifacial yield gain. And we are doing a lot of sensitivity analysis, and these analysis match pretty closely with our field results. Of course, if higher albedo, you see more bifacial gain, and this is well understood. Same with bifaciality, but the big thing is view factor, which is most applicable to the trackers. And as of course, you decrease the GCR, you get better bifacial yield. You increase the array height, you get better bifacial yield. And you increase the most important factor actually is height to width ratio. Because if you increase the height, you get more out of your bifacial, but also if you use a longer panel, you reduce that bifacial gain. So height to width ratio, the width of the PV array to the height is counts at the end of the day for the factor. So we did this test. We built a hypothetical scenario where we built NX Horizon, our one module in portrait P tracker, versus a two module in portrait, what we call 2P. And we tested these systems by side at the same height just to see what happens. And there is this large, and this curve you see on the red is the irradiance on the back side measured on the back substrate. And you see a larger cave kind of effect that's happening with a 2P system. And the average irradiance from the backside is 74 watts per meter square, whereas it's 96 for NX Horizon. And of course, 2P is going to be higher, but really how much higher? So really you can build any of the systems at whatever height you want, but the convention is usually decided based on the clearance rate when the trackers are at full tilt. And if you put the trackers, one module in portrait and two module in portrait at full tilt at 60, if you leave a clearance of 2 feet in this example, which may be because of your grade or your terrain or the floodplain you have, you see a higher height to width ratio come on 1P, which means you get a better view factor on the back, compared to a 2P where you're seeing only 59% height to width ratio. You can increase the gap between and leave space for talk cube, and that may increase the shade factors on the back, but it doesn't completely eliminate the shade because it's like having a blinder in there.
Yeah, and just to pile on, we can put 2P on NX Horizon. We just don't recommend it because you get less power and it costs more.
Yeah. So we ran a lot of the simulations. We did some field testing to validate these, and we are seeing at 3 different scenarios, apples to apples comparison. And the standard elevation is what you saw before, where if 2P is built at 2.37 meters, the 1P has to be at 1.5, and that is designed based on the ground clearance. With that, you see 1P outperforming 2P, even with a higher shade factor, about 0.3%. It generates 0.3% more energy. And these are some of the assumptions we used in our simulations. The one last thing I want to touch is the DCAC ratio. You saw TRUECAPTURE is pretty much impervious to higher DCAC ratios and clipping, but bifacial is not, because most of the energy is generated during the midday where inverter is peaking. So depending on how high you go on the DCAC ratio, you may not realize a lot of that bifacial benefit. So if you in a desert southwest location, around 1.1, 1.2 is where you start a significant loss in bifacial gain from the backside. So with that, I'll turn it over back to Dan.
Okay, great. So we're going to sum up our recommendations for maximum yield here. Number 1, we really recommend 1 module in portrait. We can do 2, but we recommend 1 for the reasons we covered. 2, we strongly recommend frame modules. Unframed is great on roofs or for fixed systems, but on trackers, having done this 30 years and built over 1,000 systems, go with a frame module. We'll come back to that in a moment. Number two, for these systems that incorporate bifacial, we recommend a lower ground cover ratio. It's really important. Three, we recommend for the tube, it's got to be a round tube, and its diameter should be limited, like in our case. Venkata covered the array height issue. That's an optimization. A few of these have asterisks, and there is site-level optimization, for example, on the array height and the ground cover ratio and the DC ratio. But also, if you're using bifacial, we recommend a lower DC ratio, definitely. Again, there's optimization required per site. And then it's outside our time to cover in this seminar today, but we strongly advise considering storage, in particular for bifacial arrays. NEXTracker has both a vanadium product called NX Flow and a lithium product we call the NX Drive that we've delivered both of those. We have multiple orders with clients we're delivering, and we think that's going to really help the productivity of these systems. On the frame thing, it applies both to trackers in general, but especially for bifacial. The frame speed installation, they improve module reliability, and we'd note UL 1703 is a static test. It's not a dynamic test. Putting unframed modules out there for bifacial and then grabbing at the edges where is the weakest point of the module is not a reliable way to build a power plant. The frame provides value. It can be a thin frame and an optimized frame, but you need a frame. That reduces the slippage, risk of damage, and then long-term durability. There's a lot of site equipment, people moving around site, vegetation management, washing. There's animals on the site, snow. Anything can happen. You want to protect the weakest point of the module, which is the corners and the edges. So that frame really adds a lot of value, especially for bifacial, because here you're trying to just grab onto the really thin edge, and so we'd strongly recommend that. So TRUECAPTURE and bifacial together, we've compared to fixed here. As Scott mentioned, there's still a lot of fixed going on. Bifacial works exceptionally well in a tracker because the more granular the size of the array, the better, and for east-west configurations on shadowing. Venkata, the results of the study you ran, would you like to cover these briefly, and then we'll turn over to Q&A.
Yeah. So this site is in desert southwest, a moderately undulating site. Some of the assumptions are on the right side, how a fixed system is typically built versus how a tracker system is typically built. And we see, of course, trackers right out generate 22% more, and the bifacial on top of it, on fixed tilt, it's about 5%, and on tracker, we see about 11%. And TRUECAPTURE is additive on top because it's still operating to maximize the yield and by avoiding shading and increasing the diffuse light capture. So it's an additional 3.5% on a moderately undulating site.
Okay, well, we packed a lot in this doing TRUECAPTURE and bifacial, but there was a lot of interest. We'll move to Q&A. Thanks for your interest.
There is a lot of interest. There's a ton of questions. So we're going to dive right into it because we don't have a ton of time left. First question for you, Dan. A lot of folks are asking about diffuse light and how the system detects for that. So first question, how does the system detect diffuse light? How does it distinguish it versus shade? And then how does AI play a part in this? Folks seem curious how it works.
On all NEXTracker systems, we have multiple weather stations already deployed and communicating with our wireless mesh network system. So we already have the infrastructure to be able to collect real-time information with a high degree of accuracy and reliability. What we're doing is we're basically adding pyranometers on site and then using that to characterize the irradiance and control it in real time. And so we buffer. You don't want the array moving around too much, so we basically do some buffering for a reasonable, which gets us most of the way to the entitlement.
Mm-hmm. And how does AI play a part here? Like, what is the system learning, and how is it iterating itself on that to improve?
Well, I'd tell you, but I'd have to kill you, Scott, since I like you a lot. if you're really interested in that's a deep dive response and seriousness. Please come to our seminar at Intersolar in San Francisco.
Okay. Okay, a little bit about bifacial. There's a few folks asking specifically, how do you bank on it? How do you get it financed? How are those boosts underwritten? How do you really, it doesn't seem like there are standards for production or standards for measuring or estimating what the impact of the albedo effect would be. So, are there things like ground covers that folks buy? How does it work? What's your recommendation for folks who want to use bifacial modules? How do they make sure they can get it financed?
First, it's a great question, and we, the industry, and especially the tracker industry, we need to work collaboratively to share information and accurate information about how these systems perform to help our clients get over the top on that. So I think it was a huge development that PVSYST now has the ability to model bifacial. Many of the results Venkata presented today were right out of PVSYST, and they correlate to our field testing. Mm-hmm. The biggest unknown is you brought up, Scott, is what the albedo is. Right. So the albedo is reflection off the ground. Now, you can go measure it on the site. There is variation on the sites over the year as they get wet and dry and with vegetation and so forth. Reasonable. There's literature. It's been presented by others out there. Sahara is like 40%. Grass and stuff is like 20 to 25%. Desert Southwest somewhere in the middle. So you can, if you have a pretty sunny site, and that has really dry conditions like the NELLIS site that we did. There's very little vegetation. Right. You can pretty much assume. You can look at, do a study of how that varies based on historic satellite images, and come up with a reasonable approximation. If you have a site with a lot of vegetation, ground coverings, which is in an early stage of commercialization, is worth looking at.
Gotcha. Dustin, one quick question for you, and Dan, feel free to jump in here too. I'm curious, it's laid out very specifically how this benefits projects that have irregular grading. I'm curious, Dustin, would this influence the way that you design a project? Would you consider not grading a site that you would have graded previously? And Dan, is that what you guys are intending for this too?
Well, I can start on that, Dan. The answer is it would affect the grading, but it would not. I can't imagine a situation where it would then preclude us to not grade the site. It might minimize the amount that we were going to, though. In general, the road to row true capture is enabling the site to get more energy than it would have given a certain problem, and that problem is just using traditional backtracking with undulating terrain. So the cost benefit there that you need to run is not. It's not limited to just the grading, of course. It's looking at what inputs went into the original energy assessment that was there, and are you bringing that energy assessment back from a negative value back to parity, or are you actually treating this as a gain on top of some baseline?
Right.
That, of course, is site-dependent and developer-dependent. In general, I would say that, and Dan, you might have a different opinion, I'll let you jump in, but I would say this would not avoid or really decrease the civil work at the site, because a lot of that is dictated by other constraints outside of just the backtracking and shading algorithm, SWIP, structural things like that.
Makes sense.
Yeah, it does make sense. And I think it depends on the client and depends on the site. And so in some sites, folks are thinking along the lines Dustin just outlined. In other sites, we did some sites in India, they just don't have heavy equipment out there for grading. And so there was no grading, and it pushed on most of those sites, and it pushed the product past where we, our spec, but they're still performing. And, the true capture enabled that. In other sites, we're seeing where there's still some grading, but it's less as a result of true capture, saving the clients in some cases, many millions of dollars on those projects.
Great. Okay, last question for you, Dan. You laid out, just 2 slides ago, you laid out a bunch of different recommendations and different aspects of what folks should be thinking about. But I'm curious what you're thinking about. Are there any other technologies you are considering or developing, or things that you've seen out there that is interesting? I'm wondering what's going on in your head.
Yeah, no, there's so much. It's so exciting. I mean, look, we're seeing, on the module side, half-cut cells. Those work extremely well on, for these applications. We're seeing movement toward that, more integrated electronics on the, optimizers in the systems. I mean, we've been very focused here on introducing the vanadium flow technology with NX Flow, because it's a storage technology, and it can be DC coupled or AC coupled. But what that does is it has a life that's commensurate with the life of the PV power plant. So you've got a vanadium sits out there which doesn't need the cooling, like in the case of some other battery technologies, 20-30% of the energy is being used to cool the battery to get long life. With some of the flow technologies, again, we're working with the vanadium, the electrolytes the thermal mass. So I think combined with bifacial, a relatively small amount of storage, ideally DC coupled, but not necessarily, can take this further. And I think, the control system we're doing with the TRUECAPTURE, getting more for the same amount of hardware, the bifacial, you're getting this more energy for the same silicon piece. As an environmentalist, this is stuff I love. Putting a small amount of storage might be able to take it a lot further. So we have some early projects with clients combining all these features, and we're really excited to partner with our colleagues in the industry on the module side, the inverter power electronics side, and the battery side to take it to the next level.
Well, very cool. Thank you.
And we'll also, for folks that have submitted questions, we've done this on prior webinars, we will answer every single question that's been put to us. And so we really appreciate your engagement. I'm sorry we don't have more time for Q&A, but we tried to pack a lot of content. Our team did a lot of analysis and optimization. We put a lot of material out there to try to be a service to the industry on what these optimizations are showing us.
Well, we might see a bunch of questions come in the next 30 seconds then. So thank you for that. I'm sure the audience will be very appreciative of that. So, well, with that, we're going to wrap it up. We're just a few minutes past the top of the hour. So Dan, Venkata, Dustin, thank you so much. Everyone in the audience, thanks for joining. Thanks for sticking around. Again, we're going to be archiving this online at greentechmedia.com for the next 3 months, so feel free to share it with other folks. Feel free to watch again. And don't forget, you can sign up for more webinars at greentechmedia.com as well for in the future. So with that, I hope everyone has a great rest of your day wherever you are, and take care. We'll see you soon.
Thank you.
Thank you.